This is problem number 3 on the practice problems request number 3. Simplify each expression, assume all variables represent positive numbers. Part A, square root of 45. So the goal here is to find a nice factor of 45, nice meaning a perfect square. So 45 you can break down into the product of several different numbers. For example, 45 is 3 times 15, but that's not helpful because neither 3 nor 15 is a perfect square. So if we're only seeking numbers that are perfect squares, and 9 is the one that we're going to want to use. And then we'll take advantage of this nice property of square roots that says you can split up a product into 2 square roots and then multiply at the end. Square root of 9 is nice. It's 3 times square root of 5, and that's our final answer. Part B, same idea, square root of 32 and square root of 18. We're going to want to split those guys up into nice numbers, factors, one of which is nice. 32 is 16 times 2. 18 is 9 times 2. Notice the 16 and the 9 were chosen so that we'll be able to pull them out. So we're going to pull the 16 outside. I'll do this one just a tiny bit shorter than the previous one. 16 comes out, 2 stays in. 9 comes out as a 3, 2 stays in. And then these are like radicals. So we get to add the numbers in the front, copy the radical part. 7 radical 2 is our answer. Part C, square root of a to the 4th, b to the 4th. So the basic idea here, you don't need to put it, but I'll put a 2 in there. That's the invisible index. The idea here is that, so first, if we wanted to, we could split this into 2 radicals, just like we did before. And one nice property of radicals is that when you have stuff like this, you get to divide that number by this number. That's how radicals work when you have a power. So our answer here is a to the 4 halves times b to the 4 halves. I don't need you to write that sentence, write that part out, but I just will highlight that that's actually kind of nice, because if I just gave you a to the 4 halves and I said rewrite it as a radical, we can probably write something that looks just like that. 4 goes up as the power, the 2 is the root or the index of the root. So this turns out to just be a squared times b squared. Part D, same idea as before. Square root of 4 can come out as a 2. Square root of x squared, again, divide those powers. 2 divided by 2 is just 1. So it's 2x to the first, or just 2x. Now we are assuming that the variables are positive. That was given in the problem. But if we weren't assuming that they were positive, then actually the square root of x squared isn't just x, would be the absolute value of x. Remember that whole business about even roots and the absolute value getting its revenge. But odd roots stay exactly as they are. So I'll leave off the absolute value just so it matches the answer key, but I just wanted to point that out. Part E, square root of y squared plus 9. It is very tempting to separate this as the square root of y squared plus the square root of 9. And the square root of y squared is y, or absolute value of y if you're picky. Square root of 9 is 3. So y plus 3. It's tempting. It is also wrong. So don't do that. Don't do any of that. Lots and lots of lines through this because it is way wrong to do that. So I don't know how we can phrase our answer. Just say there's nothing to do. That one is simplified as much as possible. Okay, part F, plus or minus the square root of 162. So the goal here is to find nice numbers that go into 162, nice meaning perfect squares. So you can use your calculator to help you. Take your time. I'm about to say the answer, so if you don't have it, you might pause the video here. Well, 162 happens to be 81 times 2, and 81 is a quite nice number. Plus or minus is just getting copied. 81 comes outside as a 9, 2 stays inside, and we're done. Plus or minus just got copied all the way down. Part G, negative 8z to the 9th inside of a cube root. So I'll go ahead and rewrite this as cube root of -8 times cube root of z to the 9. Again, radicals behave nicely when there's a product inside. Cube root behaves just like a square root does. Okay, cube root of -8, does that even exist? Sure, it's the even roots that have trouble with negative numbers, but odd roots, like a cube root, no problem at all. Cube root of -8 is -2. Now what do we do with the powers here? Well, just like before, we're going to divide these guys. That's our nice little shortcut. So this is -2 z to the, and then 9 divided by 3 is 3. That one would not require absolute value, even if we were being picky. Absolute value only comes in when we have the even roots, the even index, not the odd ones. Part H, 4th root of 2m cubed times the 4th root of 8m cubed. So here's the bad news. The bad news is I could split it up and I could write it as the 4th root of 2 times the 4th root of m cubed, which is fine, but the difficulty times some other stuff. But the difficulty here is that the 4th root of 2 is nothing nice. And then if I divide these numbers, I get 3/4, also nothing nice. So how about instead of doing that first, we'll mush these things together first. Opposite direction from what we've been doing most on this page. So I'm going to make a 1/4 root by multiplying these two things together on the inside. And I'll continue to mush things together. That's a 16m to the 4th. Aha! Now we have two things in here that are nice. So I'll split it up. You don't need to write this step, but I will. Fourth root of 16 is a nice number. That is 2. The 4th root of m to the 4th. Again, use the idea of dividing here if you don't see it. The 4th root and the 4th power cancel, so we get 2m. Again, technically it should be absolute value of m right there, but we'll leave it because we're assuming the variables are all positive. Part I, 3 radical 12 minus 7 radical 72. The same idea as some of the earlier ones on this page. We're going to want to split these things up into factors, one of which is nice. So 12 is 4 times 3 minus 7, and then what is 72? Well, it's 9 times 8, but we can actually do better than 9 because 36 happens to go into 72. Goes in twice. It's totally fine if you don't get the biggest factor that goes in right away. If we were to have written 72 as 9 times 8, the 9 would be something nice. The 8 would be something that you'd have to resplit because there's still a perfect square that goes into 8. And eventually you'd get to the right answer. So it's okay if you don't see the biggest one straight off the bat. Let's just put a line here to separate these problems. Okay, the 4 comes outside. Square root of 4 is a 2. Root 3 stays there. Notice I copied the 3 straight down here. Minus 7, that one gets copied. What comes outside, 36 becomes 6. Square root of 2 is copied. Notice I've also put some multiplication signs in there. There's hidden multiplication right there, 3 times the square root of 12. 3 times the square root of 12. So we multiply in the front. 3 times 2 is 6. Radical 3 is copied. Minus 7 times 6 is 42. Radical 2 is copied. And do these radicals combine? You've got a radical 3 and a radical 2, and there are a lot of things you might think to try to merge these together, but try as you might, there's nothing to do. So don't do anything. Can't merge them together because they are not like radicals. Part J, 5 times the quantity 2 minus radical 7. So this is our old friend, the distributive law. 5 times 2 is 10. 5 times radical 7. Don't you dare put that 5 inside. It stays right in the front. 10 minus 5 radical 7. Can we combine these things? No. One of them has a radical 7. The other one doesn't. Okay, and finally part K, negative the square root of 243. Okay, negative gets copied. 243, looking for something nice that goes into 243. I'll just list real quick here the numbers that I'm calling nice, the perfect squares. These are the candidates. If you have a number like 243 and you don't know what it factors into, well, don't just try any old thing, only try the perfect squares. 4, 9, 16, 25, 36, etc. And you're looking for the biggest number in that list that goes into 243. So if you haven't found it yet, maybe pause the video here first and try to find one. There's a pretty big one that I haven't even gotten to in my purple list that goes into 243. But if you're ready, I'll go ahead and write the answer here. 243 is 81 times 3. 81 comes outside as 9. 3 stays inside. Negative gets copied the whole time. Negative 9 radical 3.